What's sensation?
You don't know what sensation is?
Well, why don't you tell me?
Sensation is when these special receptors in the sense organs are activated, allowing outside stimulus to become neural signals in the brain.
Whoa. What are special receptors?
Special receptors are called sensory receptors, and they are specialized forms of neurons, which are cells that make up the nervous system. These receptor cells are stimulated by different kinds of energy. For example, I need the light.
Dude, what the heck?
I was showing you an example of your eyes getting triggered by light from your sensory receptors. Another example is when touch is triggered by pressure or temperature.
So there's a dude, right? His name was Ernest Weber, and he investigated sensory abilities by detecting the smallest differences between two weights that can be looked or found. Now, he also came up with this law called Weber's Law, named after him, and it's just noticeable differences. The abbreviations are J and D, aka difference thresholds, right? Okay, and so J and D simply means the half the time you can notice the difference between two different objects.
Wow, that's pretty cool.
Yeah, that's so interesting, right?
Yeah, I didn't know that.
Yeah, it's with their sensory abilities. We learn a lot from psychology.
Psychology, that's it.
Whoa! Oh my gosh! Guess what I just read in this magazine?
What did you just read?
So interesting. Okay, so there's this one article about after images, and what an after image is that when you stare at an object for a short period of time and then it's removed, you can still see the object just like floating around, like if you're looking at the wall.
That sounds like the opponent process theory.
What is that?
It's the color perception that uses the four primary colors. So red and green pair up, and blue and yellow pair up in your eyes, in the cones of your eyes.
Oh yeah, you see that flag right here?
The yellow and green one?
Yeah. Okay, see that white dot in the middle?
Yeah.
Stare at that for 30 seconds.
Okay.
Okay, glance at the wall and tell me if you can see anything.
I see the American flag. Ta-da!
Hey girl,
Hey!
I really love that blue top.
My
It's
top
so
is red.
cute. No, it's not. It's blue.
It's red.
Amy, it's freaking blue.
I bought this shirt, so I should know what color it is. I think you're colorblind.
What's colorblind?
You don't know what colorblind is?
No, what is that? I'm not colorblind.
You say colorblind?
Yeah, she's
You know there are
freaking crazy.
3 different types of colorblindness, right?
There are?
Yeah, okay, so the first one is monochrome, and that's when you don't have cones, or you have cones and they don't work. The cones in your eyes.
Oh,
Come on. Okay, then the other two, they're opposite to each other. The first one, which is a little bit more common, is red and green colorblindness. That's when you can't see red or green, but you see the world in blue and yellow and shades of gray. Now the third one, which is opposite to the second one, is blue and yellow colorblindness. That one's a little bit more rare. And you see the world in reds because her shirt is red, okay? You see greens.
It's blue though.
It's red.
Okay.
You probably have red and green color blindness. Her shirt's red. So that means that since you can't see it, that you have red and green color blindness. Now the third one, hi dog. The third one is blue and yellow color blindness, and that's when you see the world in reds and greens and shades of gray as well.
So what you're saying is, if I have red and green colorblindness, I can't see red and green.
You
So
can't.
that's why I think her shirt is blue?
Yes, we think it's blue.
Oh my gosh, I had no idea.
Exactly.
Now you know.
That there are
Red.
3 different kinds of color blindness. Does that make sense?
That makes sense.
Okay, do you guys know anything about taste buds?
I know they're on your tongue.
I know I burned my tongue the other day.
I know we have like a lot of them.
Yeah, okay, well anyways, let me tell you about taste buds. Okay, so taste buds, aka taste receptor cells, that's what they're also called, guys. Okay, so there's this thing called gustation, which the neurons are in your mouth that help a person detect a taste. And so the taste buds are mostly located on top of your tongue, but there are also some locations of the taste buds that are on your cheeks, under your tongue, and on the top of your mouth. Yeah, so yeah, you're able to taste more, I guess. I don't know. But anyways, so there are also 20 receptor cells that are on each taste bud. Isn't that crazy? And then every 10 days, your taste buds replace. It's just like you said about burning your tongue, your taste buds will eventually replace. That's why it won't hurt.
Well, girl, it's been 3 days. Those 10 days need to hurry up.
Well, be patient. Okay, and then a person's taste buds can vary, which means that you can have, some people can have more than others. So, like, people with more are also called super tasters, which they need less seasonings on their foods, because if they have too much, then it'll be too much for them, and then they're gonna be like, gross, this is nasty.
Oh.
And then also, so when you eat something, there's a signal sent to your brain that will detect like what you're tasting. So, like with your Sour Patch Kids, put one on your mouth. Ah, sour. That's because the brain signals something to let you know what that means. Okay.
My taste is for bitter, and this is a bitter melon. Ew.
My taste is for salty, and I have popcorn. Salty and buttery.
My taste is umami, chicken broth. Tastes like chicken.
And mine is for sweet. It's like Hostess cupcake. Mmm.
My taste is for sour, and it's a Sour Patch candy. Sour.
Okay, what you just saw was an example of the 5 basic tastes.
Okay guys, so in 1916 there was this German psychologist named Hans Henning, and he discovered the 4 primary tastes: sour, sweet, bitter, and salty. And then around 1996, Lindemann, he noticed that there was a 5th taste, which is known as umami, which is a brothy, soupy taste.
Interesting.
Okay, and so there's this guy named Dr. Ikeda, and he was successful in finding the substance in kelp that that generates the sensation of umami. So umami is like the soupy, brothy taste that she was talking about, and then so also that's also known as monosodium glutamate, so MSG, and you can also find it in breast milk too. It just kind of enhances like the flavor.
Also, there's 5 different taste sensations, and they all work together with the sense of smell, texture, temperature, heat of food to produce the thousands of taste sensations that we all get.
Well, that's just like, have you ever had a cold and like all the food just tastes like gross, like it has no flavor?
Yeah.
Like it's because like you can't taste like salty, sweet, bitter, sour because your nose is all stuffed up. And also too, like because your nose is all stuffed up, you don't get the sense of smell because you can't smell. So you don't get to have that variation as well.
It happens to me a lot whenever I get a cold.
Okay, so now I'm going to talk to you about the difference between habituation and sensory adaptation. Habituation is when you're hearing something, but because you're not paying attention to it, you don't really hear it. But like your senses are still responding to the sound. That's just like, for example, like when you're at a party and I'm sitting here talking to somebody, chatting it up. But I can only hear this person because I'm tuned out to everything else that's going on. Because all my attention is focused on this, and I'm not paying attention to everything else. And then when there's that awkward silence, you start hearing stuff that's going on around you. And this is the way that your brain deals with unchanging information to your ears. Now, however, even though constant unchanging info from your other senses, like your touch, smell, vision, and taste, even though those can be ignored sometimes, it's not habituation. It's not the same thing. That's called sensory adaptation, which is basically like when your senses, touch, smell, vision, and taste, your sensory receptors, those cells themselves ignore the stimuli to your sense. So like that's like with anything that touches your body, like earrings or clothing. Like you don't really feel it throughout the day. Because your cells themselves are ignoring it until you're like, hey, I have a sweater on and it's touching my skin. But that's the difference between that.
So the pain gate control theory is basically when pain signals pass through a gate that's in your spinal cord. And the only way that that gate can be closed is if your brain sends other signals throughout your body, if your body sends other signals that aren't from your spinal cord. And stimulators of pain releases a chemical called substance P. And when that happens, other neurons, because of other activities, other neurons that send messages through the spinal gates. And the feeling of pain, it releases endorphins in the spinal cord, and then from there, releases into the body and the brain and sends messages throughout your body. An example of the pain gate theory. Let's watch.
My name's Ashani. Woo! I'm Priscilla. Hi. And I'm Amy.